Section 03 in advanced geometry, refreshing our memory on how to solve a quadratic equation. Explain to me why this is a quadratic equation again. Biggest exponent is a 2. There's many ways to solve a quadratic equation. Last year you should have learned to factor, you should have learned to do the quadratic formula, you should have learned to complete the square, and etc. Many ways to solve a quadratic equation. Today we will be doing the square root method. We'll be doing easily factorable problems, and we will be doing frowny face factoring. I have some weird lingo of why it's called that. You know, if you don't understand why it's called that, don't worry. Just what do you need to do? The square root method. I'm telling you verbatim right here when you can use it. When the b value is 0. Where's b located in standard form of a quadratic? Coefficient of x to the first. X to the first, right? Isn't that the number right in front of x to the first? If b is 0, what does that mean happens to all the x to the firsts? There are no x to the first. This is a quadratic equation, correct? Because the biggest exponent you see is a 2. Are there any x to the firsts in it? Yes or no? So that's the easy one. All we have to do is get x squared all by itself on one side of the equal sign. Is x squared all by himself on one side of the equal sign? So then we get rid of the square by square rooting. What's the square root of 25? You sure it's just 5? Yeah, 5 or negative 5, which you may have seen plus or minus 5. You know, one of those. Plus or minus 5, they mean the same thing. 2 answers when you square root a positive number. Then we put our solutions in the solution set. The solutions are 5 or negative 5. All that is to help you with the ACT, to help you with state assessment, the way they write stuff. You know, if it's weird to you and you've never seen it, then you do very bad. But if we keep practicing all this crazy set notation stuff, it won't be that hard for you. Next one, why can we use the square root method? That's what you have to do. Talk yourself through it. Why can I use the square root method? No x to the first, only x squareds. Get x squared all by himself, is he? Number 2, right here. Yes or no? Yep, so square root both sides. Square root of 49 is plus or minus 7. Solution set, 7 or negative 7. Awesome. Number 3. Why can we use the square root method? You're going to get really tired of me saying this today. This is how you approach each problem. Why can you use the square root method? No x to the first. Is x squared all by himself on one side of the equal sign? So let's subtract 5 from both sides. 21 minus 5 is 16. Man, I love 16. What's so great about 16? Perfect square. So we can square root both sides and we'll get a nice, neat integer. Square root of 16 is plus or minus 4. Those came out pretty. 4 or negative 4 are the solutions. Number 4, square root method because there are no x to the firsts, correct? Is x squared all by himself on one side of the equal sign? Yes. So let's square root both sides. Problem. Is 8 a perfect square? Nope. So what we have is x squared, x equals plus or minus, won't there always be 2 answers, correct? The square root of 8. So far so good. Does that make sense to you what it is? Square root of both sides. Now, do you remember simplifying radicals? Where the square root of 8 can simplify? Where you break it up into 2 radicals right here. And you put the biggest perfect square that goes into 8 evenly. What is the biggest perfect square? 4 goes into 8. How many times? 2 times. And see this guy on the left right here? We can take the square root of 4 very easily. What is the square root of 4? So hold on. We got x equals plus or minus. This is the 2. And then we have a square root of 2. So just for fun, let's simplify this one, just to simplify some more radicals. Square root of 50. What's the biggest perfect square that goes into 50 evenly? So you split it up into 2 radicals. 25 goes on the left. And then how many times does it go in there? That's really 5 square root of 2. Square root of 72. All right? That one's always a pain in the butt. It's like, what's the biggest perfect square that goes in there? Because people are like, oh, you know, 9 goes in there. Right? 9 goes into 72, but the biggest perfect square that goes into 72 is 36. And it went in there how many times? So that's really 6 square roots of 2. Because if you did reduce it like this, if you said 9 goes in there 8 times, you'd get 3 square roots of 8, but can't the square root of 8 also simplify anyway, right? Because that's like me saying, all right, what if I told you to reduce 4/8, and you do that, and you go, I reduced it to 2/4. Yes, you reduced it, but you didn't completely reduce it. So find the biggest perfect square. Number 5, discuss with your neighbor, why are we using the square root method, besides the fact the instructions tell you to? Reason why? No x to the first. Get x squared all by itself. What would you do first? Divide by 2 or subtract 3? Subtract 3 from both sides. 2x squared equals 242, right? X squared is still not all by himself. What do you need to do next to get x squared by himself? Divide by 2. X squared equals 121. Do you like the number 121? That's a perfect square, right? X equals 11, right? I love it. Dude, we're a good group. I'm going to like this year. 11 or negative 11. You cool with that? Next one. Square root method, because there's no x to the first, correct? Is x squared all by himself? Yes. Let's square root both sides. If I showed the work, any kind of problems appear? Can't square root a negative number, right? You cannot think of two numbers the same that multiply together to be -4. In the real number system, you can't. But next year, you will learn how to do that with imaginary numbers. So what we have here is no real solutions. That's why we don't put no solutions, because there are solutions, my friends. They're imaginary solutions, but there are no real solutions to that situation. Good deal? Square root method. No x to the first. Yes? Do that. Sorry, we forgot to put this in set notation. You've got 2 square roots of 2 and -2 square roots of 2 in the set brackets. Thank you. But I got so excited simplifying radicals, I just lost my mind. Good deal? That's the square root method. Now, those of you that had me or Mr. Peterson last year, we talked you through a factoring cheat sheet. If you look at the back side of this piece of paper, it is on there, the factoring cheat sheet. Square root method is something you've got to recognize on your own. If there are no x to the firsts, you automatically use the square root method. When there are x squareds and x to the first, here's the factoring cheat sheet. The very first thing you look for is if there's a GCF that can come out. For example, do you see how there's, sorry, my pen froze, 2x squared plus 5x? See that green thing right there? Is there a common factor between both of those? Number-wise, no. Between 2 and 5, there is no number. Variable-wise, doesn't this have some x's in it and that have some x's in it, correct? So you're always looking, the first thing is there a GCF? If there is, take it out. If there's not, continue down the cheat sheet. You want to know how many terms there are. There's either going to be 2 terms or 3 terms in the simple factoring problems that we'll do this year. If there are 2 terms, there is only one way to factor that. That is if it is a difference of squares. Remember, difference means subtraction, so it's got to be a subtraction problem. And the 2 terms that they're in there, they both have to be perfect squares. Isn't 4x squared a perfect square? Because 4 is a perfect square and x squared is a perfect square. Also, 9 is a perfect square. That is called a difference of perfect squares. We just abbreviate it difference of squares. That's a simple one because it factors into what we call conjugates of each other. You just take the square root of 4x squared, which is 2x. Sorry, set it up with 2 parentheses. 2x leads off in both parentheses. You take the square root of 9, which is 3, and in one set of parentheses you have a plus, and in the other set of parentheses you have a minus. That's nice that I have that typed out for you already, so you don't have to write it. These are called conjugates because it's like the exact same set of parentheses with different signs. You heard that word before? Conjugates? Okay? That's the only thing you can do with 2 terms. If there's 3 terms, you should work your way down the list. The first thing is if it's a perfect square trinomial. Perfect square trinomial, there's 3 things to check for. Here's the 3 things, all nice and typed out for you. The first term has to be a perfect square. See this example? Is that a perfect square? Yep. The last term has to be a perfect square. and you have to look at its sign also. It has to be like a positive 16. It can't be negative 16 because negative 16 is not a perfect square. Isn't that a perfect square, right? But then the third thing to check for is if you took the square roots of each one of these and put them above there, like you'd have a 3x and you'd have a 4, and whatever sign this is, you put that sign in there. If you took twice the product of those, meaning multiply them together, isn't that the product? What would you get when you multiplied those together? 12x, right? Twice that is how much? 24x. Is this middle term twice the product of those square roots? That means he's a perfect square trinomial. If it is, it factors quite simply to whatever this dude is, quantity squared. 3x plus 4 quantity squared. See this again. This is a perfect square trinomial because he's a perfect square, he's a perfect square, and twice the product of their square roots, you'd have an x and a plus 5. If you took the product of them, you get 5x. Twice that is 10x. But I wanted to use the negative. My bad. I didn't read close enough. Use the negative because that sign right there is negative. Perfect square trinomials. We won't deal too much with those, but you'll need to know them in Algebra 2 as well. Easily factorable, that's the one you're really comfortable with. You probably did hundreds of those. Why do I call it easily factorable? Because the a value is 1. Remember, a is the number in front of x squared. If the a value is 1, you find two numbers that multiply together to be c and add together to be b, right here. See that? Two numbers that multiply together to be 10, add together to be 7, that's 2 and 5. And we'll come back to frowny face factoring because you're all bored to death right now. Because they ask us right here to do all of these as easily factorable. All of these are easily factorable. I just made up that name because when do I know they're easily factorable? The a value is 1. Now it doesn't mean that every quadratic with an a value of 1 will factor, but if the a value is 1, you want to check to see if it's easily factorable. Isn't the a value 1 right here, correct? I need to find two numbers that multiply together to be 3. That's the c value, and add together to be negative 4. So you're listing multiples of 3. Well, the only multiples of 3 are 1 and 3, correct? And those don't add together to be 4. Excuse me, negative 4. But instead of a 1 and 3, what else could you have that multiply together to be a positive? Two negatives. So what you got to figure out is, what are the signs have to be? Should they both be positive, both be negative, or one be negative? If this is a positive number, the signs have to be the same, right? Because two numbers that multiply together to be a positive either have to be positive and positive or negative and negative, correct? If this is positive, the signs are the same. Well, since this is negative right here, you know these two dudes have to both be negative because a negative times a negative is a positive, and a negative minus another negative right there is going to be negative. So all you do, whatever variable you have, that leads off each parenthesis, and it's still equal to 0. Good deal? The two numbers that you found go in the parentheses. One of them was a minus 1. The other one was a minus 3. That's it. That's factoring it. We just unfoiled it, if you will. If you would FOIL this back out, you'd get this. First terms times each other is x squared. Outside terms times each other is negative 3x. Inside terms is negative x. And then the last term times each other is a positive 3. And you combine your like terms, and you'd get that guy right here. This is an equation, though. We can solve him. We broke him down to a linear times a linear. We use what's called the zero product property. What value of x would make this guy turn out to be 0? If x was how much? 1. If I put 1 in there in both spots, wouldn't this turn out to be 0 times negative 2? Right? And doesn't that equal 0? So if x equaled 1, we'd be in business. Or what value of x would make this guy turn out to be 0 if x was 3? There's our two answers. We put them in a solution set. Sometimes. The question was asked, do we make out a list of multiples? I do that when I can't find the two numbers. Yep. Okay. The next one. Is number 8 easily factorable? Even though it's in the section and you know it, how do you know it's easily factorable? A is 1. Why can't we use the square root method, though? Like, why can't we just start square rooting stuff? We got y's to the first. So what we do is let's find two numbers that multiply together to be 4 and add together to be negative 5. let's think about their signs first, because that's the hardest part. Should the numbers both be positive, both be negative, or one of them be negative? Tell me which one of those can't happen. If one of them was negative, it wouldn't work, right? Because isn't a negative times a positive turn out to be a negative number? The signs have to be the same here. So when you know the signs have to be the same, look to him, and he will tell you what they need to be. Should they both be positive or both be negative? Both be negative. So let's start listing out multiples of 4. First, I start with 1 and 4, but I know they both have to be negative. And I check to see if that's a bingo. If I add those together, are those my bingo numbers right there? Yep. So that means I'm done. I found my two numbers. I'm asking you, please, when you find your two numbers, put them right here. It will make things so much easier if you put the two numbers right there. And now you just set it up. Since A is 1, we don't need to do that whole factor by grouping and that long put it into a 4-banger and all that stuff. We go straight to the answer because this is easily factorable. It's y, whatever this is, minus 1. And isn't this sign minus also? But there's something missing. What's missing? It has to be equal to 0. If it starts an equation, it must remain an equation the whole way. Now that we've done this, the whole reason why is because we can't solve a quadratic very easily, but can't we solve some linear stuff? Isn't this dude in here linear? Everything's to the first power. Isn't this guy in the red set nice and linear? We can solve that like a piece of cake because it's two linear things, a red thing times a red thing equaling 0. I said red twice. A blue thing times a red thing equaling 0. What would make the blue thing turn out to be 0 if y equaled how much? 1. Or what would make the red thing turn out to be 0? 4. And there's our two answers. 1, 4. So we'll try another one. So on number 9, again, they're asking us to factor this quadratic equation. Not every quadratic equation can be factored. If the a value is 1, it's a real easy process. Find two numbers that multiply together to be c, then add together to be b. Think about their two signs first. Both positive, both negative, or one negative. If that's positive, the signs have to be the same. Should they both be positive or both be negative? Two numbers multiplied together to be 9. Well, how about 1 and 9? Wouldn't that be a first place to start? Do those add together to be 10? There's the bingo right there. So we make it into m plus 1 times the quantity of m plus 9. And please don't forget that it still has to equal 0. That's the easy part right there. That's the easily factorable. No work required. Just copy the pattern. Then values of m that make this true. We need this to be 0. Since we have two guys times each other equaling 0, if you put negative 1 in there, wouldn't that turn out to be 0 right there? Or if you put what else? What could make this 0? Negative 9. And then there's our solution set. Number 10 is also easily factorable because the a value is 1. You can't use the square root method because there's also x to the first, but something's different. It's not ready to rock yet. Why not? The only way you can factor is to get it equal to how much every time? 0. So you got two choices of what you could do. You could take this guy over here if you wanted to. That would cause a major problem, though, because if you moved him over there, what would he become? Negative x squared, and then is the a value 1 anymore? We don't want to do that. What if we move the other stuff over here? So where we had 1x squared minus x minus 2 equals 0. Cool? Then we want to find two numbers. Think about their signs. If they have to multiply together to be negative 2, both positive, both negative, or one negative? One of them has to be negative because that's the only way that things can multiply out to be negative, a positive times a negative. So you and your pal, see if you can find those two numbers. Two numbers that multiply together to be negative 2 and add together to be negative 1. Remember, one of them has to be negative. What I do is I make myself out a list. 1 and 2 are the only two integers that multiply together to be 2, but one of them had to be negative, so I have like this double list right here. Which one of those do I want, the top one or the bottom one? Which one? These. So I circle them. And then I've got x plus 1 times the quantity of x minus 2, and it still equals 0. Whatever sign was in front of those numbers is the sign that goes in front of those numbers right here. That's why this is a positive 1 and this is a negative 2. Just watch me for a second. Just want to show you what we did. We unfoiled this. Watch me foil this. FOIL means take the first terms times each other. X times x is x squared, correct? Outside terms times each other, negative 2x. Inside terms times each other, 1x. Last terms times each other. If I clean that up and combine these like terms, isn't that what we started with in the first place right here? They're like equivalent things. But what we wanted was we wanted the blue stuff because that is easily solvable. Since it's a linear guy times a linear guy, x could equal negative 1 or 2. What's the first move you'd have to do on number 11, baby? Get it equal to 0. Get it equal to 0. I did use positive 1 and negative 2, but then the solutions are the opposites of those to make them equal to 0. Does that make sense? We had to solve that. So, find two numbers, compare them with your neighbor. That's the hardest part about factoring, is finding those two numbers. Sign-wise, one of them has to be positive, one has to be negative, because that's negative. So multiples of 5, 1 and 5, that's it. Those are the only multiples of 5, correct? Which one has to be negative, though? The 1 or the 5? The 5. Then x plus 1 goes in there. X minus 5 goes in there. And then solving it, you do the old opposite of what you see. And then put it in the solution set. Last one. Do the whole thing. Talk yourself through it. Last easily factorable one, that is. So back in algebra, the toughest part was finding the two numbers. Let me open this and put it in a new page for us. Tell me about the signs. Both positive or both negative, or one negative? Both negative. Since he's positive, same sign. Whatever he is trumps. So 1 and 36 is where I'd start, but they both have to be negative. Do those work? Do they add together to be negative 12? Nope. Negative 2 and negative 18, do those add together to be negative 12? Negative 3 and negative 12, do those add together to be negative 12? Negative 4 and negative 9, do those add together to be? So a lot of people quit. They're like, that's it. Negative 5 does not go in there. Does negative 6 go into 12? Or 36, sorry. Negative 6 times, correct? Do these add together to be negative 12? And here's the secret. When the two numbers that you found were the same, that means that this is a perfect square trinomial. Because is the first guy a perfect square? Is that a perfect square? Is the last guy a perfect square? And is the middle guy twice the product of their square roots? If you was to bring the negative down, twice the product of their square roots. So instead of writing this, which is not wrong, you can write it like this instead. Isn't x minus 6 times x minus 6 really x minus 6 quantity squared? And then you could actually use the square root method, right? You could use the square root method since there's really just one term. I'm trying to change colors. Because you always take a blind eye to what's inside the parentheses. Isn't the quantity squared all by himself on one side of the equal sign? So you'd square root both sides. And you'd be left with x minus 6 equals, you're supposed to put plus or minus. There's no such thing as plus or minus 0, though. What does x equal? X equals 6. You wouldn't say x could equal 6 or x could equal 6. I mean, it just doesn't work that way. It's like, give me $10 or give me $10. It's like you gave him the same option twice. It's like the only answer to this situation is 6. And what that means is if you'd graph that parabola, because isn't this a quadratic equation in the first place? Correct? It's a parabola. Does he open up or open down? Open up. He crosses the x-axis at 6, if my parabola would do it. Only one place. This is the point 6, 0 right there. Other parabolas, can't they cross the x-axis in two places for right? But if it's a perfect square trinomial, it only touches the x-axis at the vertex. Yeah, those were easily factorable. Why were they easily factorable? A was 1. The next case, I called it frowny face factoring. Why is it frowny face? Because frowny face is sad, and this is a lot of work right here. The A value is not 1. With me? A value is not 1. I'm a big fan of putting this, because what you have to do is multiply A times C. I put that little frowny face right there also. That's 8 times negative 3. And I put that right above there. That's just the way I roll. I know some of your math teachers in the past taught you a different way, but I do this frowny face. I need to now find two numbers that multiply together to be a negative 24, but add together to be 2. So make yourself a list and determine your signs first. If they multiply together to be negative 24, tell me about those signs. Both positive, both negative, or one negative. One of them is negative. So multiples of 24, but one of them has to be negative. You don't have to write all that list out, but go through them. Find yourself two numbers that multiply together to be 24, with one of them positive and one of them negative, and they add together to be 2. Nope. Trying to make a list of multiples. 4 goes into 24 6 times. If one of them was negative, would I have a bingo? This one right here, correct? Another way you can think of it after you've done this many times is if they're supposed to multiply together to be basically 24 and add together to be 2, or subtract, one of them has to be negative, they have to be 2 apart. They have to be 2 apart, right? Because they're supposed to add together to be 2, but one of them was negative, so you're subtracting them. Cool with finding the two numbers. So whenever you find the two numbers, I don't care if you make the list or don't make the list, but if you're staring at the piece of paper, make a list. Write those two numbers right here. Awesome? But here's where it takes a lot of work. We need to split this trinomial, which has 3 terms, into 4 terms. So what we do, it's always the same process. Whoever the first guy is, he will lead off every time. That 8x squared leads off. Then we take these next 2, and in any order we want to, we put an x with them, but it's really, there's a smart way and a not so smart way. If one of them was negative, use the negative one first, and I'll explain why later. But if one of them is negative, put the negative guy first, but we're going to have x's with him. The other one is a positive 6, correct? So we plus 6x. There's 3 terms. The 4th term is that minus 3. He comes down for the ride also, and it's still equal to 0. And just to explain what we did, do you see that we have taken this red thing right here and totally rewrote him into this? But see the green stuff? If you combined like terms, how much is that? What's negative 4x and positive 6x? It's really this 2x. All we did was split that 2x up into the negative 4x and the positive 6x. Exact same thing so far. We good? We're not done. We need to now what I call double group it. Put these two together in a group and put these two together in a group. Okay? And now we take out the GCF in each group. Look at group number 1. Between an 8 and a 4, always think of the numbers as positive. What's the biggest number that goes into both of them? 4. XY, this has x's, that has x's. Take out the smallest amount that you see. Aren't we taking out a 4x for a GCF in the first group? Cool? If you've heard this called factor by grouping, that's what it's really called. Okay? I call it frowny face factor. Then you divide. 8x squared divided by 4x is 2x, right? 8 divided by 4 is 2. X squared divided by x is x. The minus sign comes down. And what's 4x divided by 4x? It's 1. You have to have 2 terms left in there inside of those green parentheses. Cool? Then the real trick is, whatever this guy's sign is right here, that's the type of GCF you have to factor out. That's why we want him to be a positive number. Isn't this a positive 6x? So we will factor out a positive GCF. Between 6x and 3, what's the GCF that we can take out? 3 is the only thing we can take out. But it was positive. A lot of people don't put the plus. You've got to put the plus. And then what's left over, you know you do it right if whatever this group is right here, if that's a 2x minus 1, this one has to be a 2x minus 1 also, otherwise you didn't do it right. 6x divided by 3, isn't that 2x? Minus comes down. 3 divided by 3 is 1, came down, and of course, it's still equal to 0. Cool? One more move. We need to regroup. The GCFs that you pulled out become a group of their own. You put the 4x and the plus 3 together in a group. The common group is also there. And no, it doesn't matter which one comes first. If you had the red one second and the blue one first, it's the same concept. Okay? But it's still got to be what? Equal to 0. And now we solve this. It's the zero product property. I'd like for the red thing to equal 0, and then I'd like for the blue thing to equal 0 separately. So I'll show you some work off to the side which you do not have to show. I'll show you a shortcut in a second. But don't you want to know when this red thing is equal to 0? Isn't that what we're trying to do? What's the first move you'd have to do? Subtract 3. And then you would have to divide by 4, right? And what it always turns out to be is it's the opposite of this guy. Isn't that a plus 3? Don't we have a minus 3 in this situation? Because he always has to move over this guy. X could equal opposite of 3 over 4. Or, let's see if you can use that trick on this one. Opposite of this guy over this guy. So what would you have? 1 over 2. Always works. Always works. Because what you're really doing, if I wrote this generically as ax plus b, come on baby, my pen would work. You want to know when this generically ax plus b equals 0, you always have to move this guy over. Wouldn't you have to subtract him over, the opposite of that guy, divided by a? It's the opposite of this guy over that guy every time. If it's in this order. That's a good question. If they switch the numbers around and all that stuff, you have to be very careful. Variables first, numbers second. It works every time. So let's try it again. Oh, solution set. Negative 3/4, 1/2. Again, that was only one example. We got more to go. It's been a while. Hopefully you get more comfortable as we go. Why is this a frowning face factor situation? A value is not 1. Make the frowning face. Wow. Those multiply together to be something, but it's not 15. What do they multiply together to be? Negative 15. We must find two numbers that multiply together to be negative 15 and add together to be a negative 2. Tell me about the signs. 1 negative. Go ahead and find me those two numbers. So there's our numbers. We're okay at that. Setting this up, I call it the 4-banger because you need 4 terms. Here's 3 terms. I need 4 terms. First term, always the same as what our first term was. Second term has to be these two numbers with the variable next to them. If one of them is negative, put the negative 1 first. Minus 5n plus 3n. Who's the fourth term, though? That minus 5 up there. And he has to be equal to 0. Not in my opinion. Okay? I'll show you why. I'll do it that way in a second. Put the negative 1 first, in my opinion, easier. Because let's take out a GCF. We got a double group. What's the GCF that we're taking out in this group? Between a 3 and a 5, that's a 1, right? But do they both have some n's in them? So what's the GCF that we're taking out? N. What's left over is 3n minus 5, correct? My pen would move. What do I take out in the next GCF? Well, there's 3 and 5. Nothing goes into those besides 1. This has an n with it. That doesn't, right? You have to always take out a GCF, though, so what are we taking out? A 1. And what's left, I mean, duh, you wanted it to be a 3n minus 5. Isn't it already a 3n minus 5? So you must always take out a GCF, though. Then you regroup the GCFs The red numbers right here, it shouldn't say numbers, but the red things, they become a group of their own. The common group comes down for the ride. And now let's solve. This one's a piece of cake because there's no fractions involved with it. But it still works if you think of it as the opposite of this guy over this guy. You'd get negative 1 over 1, which is plain old negative 1, correct? Or, what about this guy? What value of n makes him turn out to be 0? Opposite of this guy over that guy. What do you get? 5/3. Opposite of this guy, 5 over 3. Negative 1, 5/3. Frowny face, a is not 1, that's a negative 14, correct? Find two numbers that multiply together to be negative 14, add together to be negative 13. Multiples of 14, I start with this. Doesn't one of them have to be negative? Boom. There's our bingo right there on my first set. Cool. Set it up as a 4-banger. 4 terms. If one of them's negative, I think it's easier, in my opinion, to put the negative one first. The negative term first, I should say. Then, double group. First two guys become a group. Last two guys become a group. GCF in the first one, 2D. D minus 7 left over there. GCF in the second group. You always have to pull a GCF out, but it's pretty simple. When you see that this is D minus 7, and that's already a D minus 7, what's the GCF that's coming out? The UNO. Then regroup. GCFs become a group of their own. Common group comes down for the ride. And then solve that, baby. How about Mr. Blue here? If you use the old opposite of this guy over that guy trick, what does D have to equal? Negative 1 over 2. Or you don't need to use the trick when the coefficient of your variable is a 1. It's just plain old 7. Right? Opposite of this guy over that guy, same thing. 7 over 1, which is 7. Then you put them in the solution set. Go for the next one, baby. Pause the video, get it done, come back and check. If you need help, I will come help you. I think I did both of them for you people out there in video land, so you could check your first one, see if you did that right, then try the second one and come back and check it with this one. If you have questions out there, let me know. But now let's move to the last one, and what we're going to do is we're going to talk ourselves through the cheat sheet. Right? Just because the instructions tell you what to do, it's like, please use frowny face factoring. Let's pretend that this wasn't in that set of instructions. You can flip that cheat sheet over, or the paper over, to see the cheat sheet. First thing I ask myself, first of all, can I use the square root method? Can I use the square root method? Why can't we use the square root method? Why not? R to the first and R squared. Is there a GCF I could take out then? Is there a GCF, baby? Nope. So, move on down the line, split 2 terms to 3 terms. This is a 3-term situation. What's the first thing to check for? Perfect square trinomial. Discuss with your friends to see if this is a perfect square trinomial. There's the rules right in front of you on that piece of paper. So, ready? Let's go through the 3 rules. What's the first thing to check for? Is the first guy a perfect square, yes or no? So what I taught kids to do was write its square root right above it. Wouldn't the square root of that be 4r? Right? So far so good. We've passed step 1. Step 2, is the last term a perfect square? It's like a brain fart. Some people don't think 1's a perfect square. Is 1 a perfect square? What's the square root of 1? 1. Bring this sign up. That's a negative. That's a negative. The third thing to check for is the middle term twice the product of those. First, multiply them together. Don't you get negative 4r? Then twice that. Is it negative 8? So is this a perfect square trinomial? If you want to go through and frowny face factor this, you go ahead. But I'm going to bring this down. The same thing that we wrote above there, right? Quantity squared equals 0. When that's a perfect square trinomial, it means you got the same thing times itself. Check it out. Is 64 a perfect square? That means you can write it as 8 times 8. Can't you factor it into 2 numbers exactly the same? This is really 4r minus 1 times 4r minus 1, if you will. You all right with that? To solve this, since you could care less about anything in here, that's a grouping symbol. Inside of there, you don't look there yet. Is the quantity squared all by himself on one side of the equal sign? Let's square root both sides. Square and a square root cancel each other out. 4r minus 1 comes down. You will usually get a plus or minus answer on the right side, but since this is just 0, we're doing... Sorry, video people, there was a knock on the door. But we usually get a plus or minus right here, but since that's 0, there's no such thing as plus or minus 0 for the square root. And then you could still think of it as the old opposite of this guy over that guy, because wouldn't you just have to bring this over and then divide by 4? So r equals how much? 1/4. How many places does this parabola cross the x-axis? Just the one, because it was the perfect square trinomial in the first place. That's what we're really doing for those of you who are just dying to get into Advanced Algebra 2. We are figuring out where this parabola crosses the x-axis at.